factor theorem, which we kind of touched on this a little bit last class in 12.1 when we were just doing our synthetic division, and we were asked the question, is this a zero of the polynomial? And then you had to write a yes or no answer. So what the factor theorem states is that if you have a polynomial and you have some linear binomial, we're going to say x minus k, and if that x minus some k ends up being a factor of that polynomial, the remainder of it should end up being 0. So if you think about it, if I go back to this quadratic graph, what would be the coordinates of this point right here? It would be -1, 0. The coordinates of this point would be -2, 0. So when I put an input of an x of -2, what's the output? 0. If I input -1, what's the output? 0. So if I were to input these into the function, I end up getting an output of 0. What did we just say was the connection between the output and the remainder when we do synthetic division? It should be the same thing, right? So when we were doing our synthetic division, blah, 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 0. Then we knew that we were going to have a 0 there. So we're looking for that remainder to end up being 0. So here's your first one. So if I had x minus 1, and we're trying to figure out if x minus 1 is a factor of the function f of x equals 2x to the 4th plus 3x squared minus 5x plus 7, we can set up our synthetic division to see if that is a factor. Now, if this is a factor, that means that it would look something like this. X minus 1 in parentheses. If that was a factor, what technically would be the 0? It would be 1. So we're going to put the 1 in the half box. Okay, because we got to think about putting that 0 in place of it. All right, so we've got a degree of 4. I don't have a degree of 3, so that means I need to put a 0 there. My degree of 2 has a coefficient of 3. My degree of 1 has a coefficient of -5. And then we've got a constant of 7. Let's race. We can get to the end first. Bring down that 2. 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. Adding gets 5. 5, 0, 0, 7. What you guys got? All right, so would x minus 1 be a factor of 7? Or another way we could say it is 1 a 0 of this polynomial? No, it's not. So I would say no. And the reason is my remainder is 7 and not 0. Bless you. So if I were to graph this function on my graphing calculator, okay, and I had the point 1, what would be the y value if my x was 1? 7. So 1, 7 would fall on that graph. It would be a point on the graph, but it's not going to be the specific x-intercept is what we're looking for, because those are your solutions. Okay? Got that? So we're looking for a remainder of 0. All right, so now what we're going to do, now we're going to talk about how we can actually factor any polynomial by knowing one of the zeros. So we have 6x to the 3rd plus 19x squared plus 2x minus 3. Now remember, back in our factoring days, if I was given 4 factors, we would try to factor by grouping. Don't write this, just watch. And you try to pull out a GCF. Well, what would be the GCF of these two terms? Just x squared. Do I have a GCF here? No. So if I only take it out an x squared, I'm going to be left with 6x plus 19, which is not the same as 2x minus 3. So I can't factor it using factoring by grouping, but we can factor it by using synthetic division, which is kind of cool. So they're telling us that one of our zeros is -3. So that means when I do my synthetic division, my remainder should come up as 0. So let's put that -3 in our half box. Coefficient of the degree 3 is 6, then 19, then 2, and then -3. So let's go ahead and do our synthetic division. Bring down your 6. 6 times -3 is -18. Adding gets us 1. -3 times 1 is -3. Adding gets us -1. Multiplying gets us +3. So my remainder is 0, which is good. It better be 0 because it's telling me it is a 0. So what's this going to look like now? It's going to be 6x squared plus x minus 1. Yeah? Is that factorable? Because now that's a quadratic. We know how to factor quadratics. We spent a whole chapter on quadratics. 6 times -1. Are there any factors of -6 that add up to +1? 3 and -2. Since my leading coefficient is 6, I'm going to put both of those over 6. 3 over 6 reduces to 1 over 2. 2 over 6 reduces to -1 over 3. So what do those look like in factored form? Good, so we got a 2x plus a 1, 3x minus a 1, and now we can't forget about the original 0 that they gave us, which is a -3. Now think backwards. If the 0 is -3, what would that look like as a linear factor? X plus 3. Good. Look at that. We just factored that polynomial. So if I were to multiply all of these out, it would have gotten me back to that cubic polynomial of 4 terms, which is kind of cool how that works. Okay. Because my degree is 3, I know that I should have 3 of these factors. Okay, that number should always align with your highest degree.
Wait,
yeah.
Where did the x plus 3 come from at the end?
So they told us that one of our zeros is a -3. So I need to turn that into a factor. So if my 0 is -3, what would it look like as the factor? So you're kind of working backwards. So if I solved this, it would be -3, right? This would be 1/3. This would be -1/2. Okay. Questions with that? All right. So now, in that problem, they gave us the 0. What happens if they don't give us the 0? And this is where it becomes a bit of a pain. We have to use the rational zeros theorem. I know this says a whole lot, but really the most important part here is this last part, the P over Q. Yeah, I just write that. All right, so if we have a polynomial function, and it's written in standard form, what's going to happen is you're going to have your constant term, and then you're going to have your leading coefficient. And you're going to create a ratio, or a fraction, of your constant term over the leading coefficient. So P is going to be all your factors of your constant term, and Q is going to be all your factors of your leading coefficient. So what's going to happen is I'm going to be given a function. I'm going to use the rational zeros theorem to make a list of all the possible zeros that could, not necessarily are, could be the zeros of the polynomial function. And then the fun part occurs is when you're trying to be a good guesser, and if you guess the right one on the first try, then you're really good. then it's just a matter of picking one out of that list and hoping that when you do your synthetic division, you end up getting a remainder of 0, because then you'll know that that is one of your zeros of the function. Okay, so we're going in the form P over Q plus or minus. P is all your factors of the constant term. Q is all the factors of the leading coefficient. All right, so let's see what this looks like. So here is our function. 6x to the 4th plus 7x to the 3rd minus 12x squared minus 3x plus 2. So part A is asking to list all the possible rational zeros. All right, so what would be my constant term in this function? 2, right? What are all factors of 2? Oops, I'm in highlighter mode. Numbers that multiply to get to 2 are what? 1 and 2, right? My leading coefficient is 6. What are all factors of 6? 1 and 6 and 2 and 3, right? So those will be all your factors. So now what we need to do is we need to make all possible combinations of ratios with your constant factors over your leading coefficient factors. So I'm going to start with 1, so we're doing plus minus P over Q right now. So all my P options are 1. So I'm going to start with 1. I could do 1 over 1, plus or minus. I could do plus or minus 1 over 2. I could do plus or minus 1 over 3. I could do plus or minus 1 over 6. Now I'm going to move to my 2 being in the denominator, or my numerator, plus or minus 2 over 1. Do I need to do plus or minus 2 over 2 again? Nope, because I already have a 1 here. 2 over 3 I don't have. And then plus or minus 2 over 6, I already have that one, right? Because that would be 1/3. So that means all of my options are 1 plus or minus a half, plus or minus 1/3, plus or minus 1/6, plus or minus 2, plus or minus 2/3. So I've got 1, 2, 3, 4, 5, 6 doubled. I've got 12 possibilities for those to be a 0 of this polynomial. Now, since my degree is 4, it means I'm going to have 4 zeros for my solution, but I don't know which 4 it is. So this is where you have to get lucky. Someone pick one.
1/2.
You want to go with 1 or 1/2? 1? All right. I wouldn't write this in your notes just in case it's not it. I'll do it up here for you guys. So let's do 1. If it works, then put it down in your notes. So I would have 6, 7, negative 12, negative 3, positive 2. All right, so 6 plus 7 is 13, 13, negative 1, negative 1, negative 4, 4. Is that going to get me a remainder of 0? No. Nope. What if I tried negative 1? All right, so if I try negative 1, 6, negative 6, 1, negative 1, negative 13, 13, 10. Is that going to get me there? Nope. Okay, so none of those work. Give me another one. 1/2?
Yeah, 1/2.
Okay, so what was it? 6, 7, negative 12, negative 3, 2. So 6 times 1/2 is what? 3? 10 times 1/2 is negative 5. Negative 17. Huh? It's just 5. Thank you. I was going to say that's going to get ugly. 5. So that's what? 7? Negative 7. Ugh. Negative 7 times 1/2 is negative 3.5. I don't think that's going to get me there, is it? 2? Oops. Negative 3. Oops, what am I doing? Negative 3, 2. We're going to go with 2. So 6, 12, 19. Oh, this is getting kind of large. 19, that would be 38. What if we tried -2? Let's try -2, see if that works out nicer. 6, -12, that's going to get us, what, -5? So then 10, -2, 4, 1. Oh boy, look at that. Whew, we got one. So that means -2 has to be one of the solutions, because that's going to get me to 0. This is what part B is to find the actual ones. All right, so I know that -2 is one of my zeros, which is nice. So I'm going to circle that. All right, what did this take me to? What degree polynomial? To the third, right? So now I have the polynomial 6x to the third minus 5x squared minus 2x plus 1. Can we factor that yet? Oops, I'm missing an x there. Nope. It's a cubic. So that means I can do one more synthetic division to take it to a quadratic. And then once I get it to a quadratic, then maybe, hopefully, we can factor it. Or if we can't factor it, we can use the quadratic formula to solve it. So let's pick another number. Which one do you want to go with? Huh? 2/3? Ugh, really? You guys are going to make me do 2/3? 2/3. 6, -5, -2, 1. So 6. So 6 divided by 3 is 2. 2 times 2 is 4. That gets me to -1. -2/3. That's -2 and 2/3. So -7/3 times 2/3 is not going to get me to 1 or -1.
Well, 1/3.
1/3. So 6, -5, -2, and 1. So 6 times 1/3 is 2. -3 times 1/3 is -1. -3. Ooh, nice. I like that. That gets us to 0, right? Okay, so there's another 0. So now what am I left with? Which polynomial?
1/6.
Well, what does this turn into? So now I have 6x squared minus 3x minus 3, which we know how to solve quadratics. Is it factorable? It is. Factors of -18 add up to -3. 6 times -3, -18, right? Factors that add up to -3 would be -6 and 3. Put them both over 6. So that gets us -1 and 1/2. So what do those look like in factored form? I'll go over here. Yeah, so we have x plus 1, or x minus 1. X minus 1, 2x plus 1. Then what would these look like in factored form? 3x, well now be careful, got to think backwards. If I had 3x plus 1, what would be the solution to that? It would be -1/3. I need it to be +1/3. So it'd be a -1. Question, Justin?
-1 and 1/2, those are possible zeros, right?
Yep.
That's what you got when you factored 6x squared ones.
Yes. Yeah. And then what would, oh, now I just erased it. What was our first one we came up with? -2. So would that look like in factored form? X plus 2, right? So that would be that polynomial written out in factored form. Now, are you ready for the cheat? Get your graphing calculators out. Graph that function.
Which one?
Original.
Okay.
So when you graph the function, you still are going to need to know how to come up with the list of possible rational zeros. So make sure you can do that.
Oh my god.
But when you get that list, I will allow you to use the cheat of actually physically graphing that function. So 6x to the 4th, let me get it typed in here and I'll show you what I'm looking at, plus 7x to the 3rd, minus 12x squared, minus 3x, plus 2. Oh, I've got a histogram going on here.
Scarlett,
Yeah.
I've been trying to graph with this calculator and it's like been giving me this. And I like put in like the
Check to see if you had a stat plot turned on. Go to hit second. These are all turned off.
How much is it?
Zoom 6.
That's gross.
There you go.
okay. It's weird.
All right.
What?
Turn off the histogram. 2 seconds here. I gotta get this histogram turned off. All right, so if you look at that graph, someone give me one of the x-intercepts.
0, 2, 1, 0.
Yeah, 0, 0 is definitely not.
Negative 2, 0.
1, 0.
Right there I have one at what? Negative
Negative
2, right? This one, I'm not quite sure, because it's in between -1 and 0. What one was that? It ended up being what? What were our solutions? -1/2 was 2x plus 1, one of our factors. This one I'm not so sure about. This one is at 1. To check it for sure, if you hit the trace button, hit trace, and then type in -2, does it come up with your y being 0? Yeah, so we know for sure that that is one of my zeros. And I know for sure that 1 is one of my zeros. So when we had that original function right here, and we made our list of all of our possible rational zeros, I could have went into my calculator and found -2 and +1, and I could have used those for my first 2 in synthetic division, which would have been nice, instead of guessing and checking all of those.
It makes us have to check our supply.
No, you're gonna have to make that possible list, but then I would go to your graphing calculator. Because my degree is a 4, 4 minus how many gets you to 2? 2. So that means then I would need to look for 2 of my x-intercepts on that graph, which there were 4. So there was one at -1/2 and one at 1/3. You just need to pull out 2 of them. Use those 2 in your synthetic division process to take it to a quadratic, and then once you get it to that quadratic, you should then be able to factor it. Okay, so try one quickly on your own. See if you can do this.
Can you practice squares?
Nope, just do this because we have to do one more type of thing yet. We have to work backwards. So see if you can do, nope, that's not what I want. So let's do 6x to the 4th minus 7x to the 3rd minus 18x squared plus 13x plus 6. We're going to write that in factored form. So what are your possible zeros that you could have? So what are all your factors of 6?
1, 2, 3.
1, 2, 3, 6. What are all your factors of 6 here?
1, 3, 6.
1, 2, 3, 6. It's the same, right? So then we make all possible combinations of constant over the leading coefficients. Let's start with 1. We could have what? Plus or minus 1 over 1, plus or minus
1 over
2, 1 over 3, 1 over 6. Now let's go to 2 being in the numerator, so we could have plus or minus 2 over 1. 2 over 2 is just 1, so I don't need to write that again. 2 over 3, 2 over 6 is 1/3, so we don't need to write that one again. Plus or minus 3 over 1, 3 over 2, 3 over 3, I don't need to do that. 3 over 6, I don't need to do that. 6 over 1, which is 6. 6 over 2, do I already have that? 6 over 3, I have that. 6 over 6, I have that. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, doubled, 18 possible rational zeros. Now, graph that on your graphing calculator. Because we're at a degree of 4, you need to get 2, choose 2 from the actual graph. Bless you.
I got it.
Hi. What did I say?
All right, so that's what my graph's looking like. We've got a bunch of options. We've got 1, 2, 3, 4 options. Which ones are the nicest ones to work with? 1 and 2. It's nicer to do synthetic division with integers than it is with fractions, right? All right, so from there, I'm going to use 1 and 2 as, oops, go away. Darn it, I lost it. All right, so if I use, let's start with 1. So up here I'm just going to write 1, x equals 1, x equals 2, so I don't forget that. So let's use 1 first for synthetic division. So plugging in 1, my constants are 6, 7, negative 18, 13, and 6.
Isn't it -7?
Yes, thank you. Bring down to 6. 6 times 1 is 6. Adding is negative 1, negative 1. So that gets us negative 19. Huh? Nope, the 0 is 1. If you're given a factor, that's when you have to think backwards. That is always going to be the 0 in the half box. So that's 6, negative 6 is 0. Don't even worry about putting in your variables. Just do synthetic division again with your next number, which is 2. Bring down your 6. 6 times 2 is 12, 11, 22. What is that? 5? 3. 19, 20, 21, 22. 3. Yep, if I could do math, that'd be good. 6 and then 0. So now what is the remaining quadratic? Good. 6x squared plus 11x plus 3. Can we factor that? Yes. 6 times 3 is 18. Factors of 18 that get you to 11. Huh? 9 times 2 though, right? 9 times 2. My leading coefficient is 6. So that'd be 3 over 2, 1/3. All right, so let's put this all into factored form. So my zeros are x equals 1, x equals 2. What do these look like in factored form? Well, these guys down here. So this would be 2x plus 3. This would be 3x plus 1. This would be, think backwards, x minus 1 and x minus 2. So that would be your polynomial written in factored form. And what's the purpose of then putting into factored form? Then I can see what the solutions are. My solutions are what? Negative 3/2, negative 1/3, 1, and 2. Okay.
Are those supposed to be towards -3?
Nope, because remember when this is just our normal factoring process. That's how we go to factor it. Because these aren't actual zeros. This is just how we go to factor it. All right, we'll save the going backwards part. For not Wednesday. The last thing we have to do is, given the zeros, can we then work backwards to put it here, which really isn't too challenging as we go. So I will be eliminating some of your homework.